This conference will now be recorded.
Good morning, all. Is it audible? Anyone please reply?
Yes, sir. Audible, sir. Good morning, sir.
Good morning, Kana. Thank you. Thank you for your response. So today we discuss about optical modes and wavegates for the unit 1. I think first two classes, some of our friends went to placement. So just the class 1 and class 2, first 5 minutes, I'll make a small overview. Then we will go to the today's class. So this is our today's agenda. First introduction, small overview about our optical fiber. Then last class we discussed about the fiber optic laws, optical laws. Okay. So we will small overview about the basic laws. Then we will go to the basic of wavegates and optical wavegates and applications. Yes. So do you have any doubt in the basic operation of the fiber optics? Anyone? Any doubt in the previous classes? Okay, good. Okay. So for fiber optic communication, normally we did the communication through electrical cables, that is for copper cables or aluminum cables. Then why we go for the fiber optic cables? Okay, so we discussed in the class 1 and class 2, again we repeat. Okay, so if you go for copper cable or aluminum cable, means the very first one is the losses. Okay, like a simple example that we discussed, in our home we are having 230 volt AC as the input, but even though TNEB sends the 230 volt, we are not able to get the 230 volts exactly. In our home, we get only for 220 or 215 volts only. So there are a lot of losses are there. Okay. So this is the first case for losses, important one. The second one, security one. Okay. Normally, in case of copper cable or aluminum cable, already you studied electromagnetic waves. Okay, electromagnetic force. So the copper cables there is a electrical cable or EMF waves on the magnetic field is there. Okay. So for optical fiber, we are sending 3 types of data. It may be audio or video, okay, or telemetry. The telemetry is nothing but recorded one. That is for it is connected with some other devices, like our ECG, okay, or any medical equipments could connect பண்ணிருப்பீங்க. Although the output it may be recorded or display or printed. That is for telemetry. Okay, good. So 3 types of operation basically we did using optical communication. Okay, yes. So basics one. So initially we are having one transmitter and one receiver. Okay. Apart from transmitter and receiver, okay, this is for optical. So this is for we are having transmitter side light source and receiver side detector. So what are the possibilities for light source? Any device we use control light source? Anyone? So LED and laser. Generally, we prefer LED, light emitting diode, or laser is using as a light source. Okay. So this is for your transmitter. So within the transmitter, we connect for light sources. Here, the light sources is nothing but light emitting diode or laser diode we can use. So in case of short distances and low power applications, we prefer light emitting diode. In case of long distances and high power applications, we prefer laser. Okay. They are detectors. Okay. So first input data is given to the transmitter circuit. Okay. Next, this input is nothing but electrical pulses. These electrical pulses converted into light pulses. That is the important one. With the help of this light source, okay. So this circuit is there. Electrical pulses converted into the light pulses and transmitted through your fiber optic cable. It is a fiber optic communication. Okay. So light source carrier is there. Okay. Yes. Your light source is light device. Light is acting as a carrier here. Okay. Then receiver end. Receiver circuit there is a detector is connected. Here the detector is nothing but photo detector. So 2 types. Generally for PN junction photo detector or avalanche photo detector we are using. Okay. Again here, normally it is connected to some other device. So we have to again reconvert light pulse into electrical pulses. Then electrical pulses is the output data that is connected with the printer or display system or any one control system. Okay. Yes. So this is the basic operation. Let's go through this one. So input signal is the electrical pulse. The electrical pulse is converted into the light pulse, then transmitted through the fiber optic cable. In receiver side, again, that optical pulses are converted into the electrical pulses. Yes, please see the diagram. So there are 4 layers are there in your fiber optic cables. First one is the core, the second one cladding, the third one buffer, and fourth one jocket. Okay. நீங்க நார்மலா ஒரு கேபிள் பாத்தீங்கன்னா ஆல்ரெடி டிஸ்கஸ் பண்ண மிக்ஸி கேபிள்ஸ் பாத்தீங்கன்னா மேல ஒரு லேயர் இருக்கும் அந்த லேயர் ஓபன் பண்ணீங்கன்னா கோர் அந்த கோர் கேபிள் கலர் கலரா இருக்கும் ஓகே இஃப் யூ ஓபன் த பிளாஸ்டிக் மீன் உள்ள வந்து 3 cables are there in your home appliances we are giving 3 cables that is for red black and green. What is red and black? It is acting as a phase and neutral. What is your green? It is acting as a earth wire. Okay. The same way here, first inner part is nothing but core. The outer part is nothing but cladding. Apart from cladding, there is a third layer is a buffer. That is for safety purpose. The final layer is your plastic or some other is there. That is considered as a jacket. Okay. Yeah. Any doubt in this? Yeah. Okay. So the main characteristics, please go through one by one. So compare it to your normal copper cable or aluminum cables. Why we go for optical fiber means these are the reasons. Okay. First one is the losses. The second one is the safety. So safety is nothing but security. Okay. Because if a simple example, bank from the OTP passwords on the mobile quorum through optical fiber cables and communication purpose. Okay. So it should be safety is there. LAN connections connected. So it be safety is the important one. Okay. Yes. Then lightweight. Because long distance, long transmission the cable is lightweight means it is easy to carry. Okay. Then larger bandwidth. That is the important one. Okay. So these are the basic characteristics, basic features why we prefer fiber optics compared with the copper. Okay. Okay. So already we discussed. Please go through one by one. So core, cladding, buffer, and jocket. Okay. Yes. Because in each and every hereafter we will go for the next modes of optical and the wave gauge or anything means we are using the 2 words are important, core and cladding. So you have to understand what is core and what is cladding. Okay. Yes. So this is a simple example. It is a multi-core one. Okay. So within the simple fiber optic cable kulla pathina nariya cores irukum, nariya cables irukum. So multi-core one. We will discuss mode of operation, single mode and multi-mode. Okay. So try to understand the inner part is the core, the second part is the cladding. Normally your pulses, that is for optical pulses, is transferred through which part? Core. Through core only we transfer. The second layer is the cladding. So even though it is entered into the cladding means it's reflected. Next we will discuss what are the reflection law, reflection, refraction, we will discuss. The next one is the buffer. What is the purpose of buffer? For safety purpose. Okay, to avoid damage of your core or cladding, we are using this buffer. Okay, the last one is the jacket. So a jacket is available in multi-colors for differentiate purpose. So red, yellow, blue, green, okay, brown, multi-colors is available. Okay. So optical law. So optical law is a very important one, reflection law. Okay, so please go through the diagram. Incident light, then a reflector. Okay, so this is the surface. This way. So this is your surface. So it is considered as a smooth surface. So this is your incident light. So incident light then automatically reflected. So incident is nothing but this is the angle between your normal or perpendicular. It is considered as a, some books they are using the word for perpendicular. Some books they are using the word for normal. Okay, both are same. So the angle between incident ray and normal, okay, it is considered as theta I. and the angle between your perpendicular and your reflected ray is considered as theta r. So what is the meaning for reflection means? What is the log space there? Means theta I is equal to theta r. That is for your angle of reflection equals the angle of incidence. That is important one. இங்க வந்து பாத்தீங்கன்னா both the angles, incident angle and reflection angle, both are same. Okay, so that is the important one in the surface of smooth surface and rough surface, etc. Please be remember. So reflection law, because the reflection principle is used in the fiber optic cable. Once you understand the reflection only, you can able to understand the fiber optic communication. Okay. Yes. Here, the speed of the light is not changes. Important one. Because if you go for refraction, will change. So reflection law, okay, there is no changes in the incidence. Theta I is equal to theta r. Also, there is no changes in the speed of light. Okay. The next one, so reflection. So please try to understand the basics one. So you are in, imagine you are in your room. Okay, இப்போ ரூம்ல இருந்து வெளியில நீங்க ஒரு ஸ்ட்ரீட் பாக்குறதா இமேஜின் பண்ணிக்கிங்க through your window. Okay, glass window வழியா ஸ்ட்ரீட்ல என்ன இருக்கு நீங்க பாக்குறீங்க. Okay, so what is the meaning of mirror? For normal glass window means you can able to view. So what are the things available in the street? So streetல கார் போகுது, vehicles or உங்க ஃப்ரெண்ட்ஸ் நடந்து போறாங்க, you can able to view. Okay, suppose that glass is mirror. It is acting as a mirror. Or coating கொடுத்துட்டீங்கன்னா it is acting as a mirror, chemical coating. Okay, அப்போ what happens? So you are not able to view what are the things available in the street, but you can see your image. உங்க image நீங்க பார்க்கலாம். It is considered as your reflection. Okay, அப்போ what is the meaning? இப்போ மிரருக்கு பின்னாடி நீங்க இருந்து அதை அப்படியே ரிஃப்ளெக்ட் பண்ணா எப்படி இருக்கும்? ஸ்ட்ரீட்ல நீங்களே நிக்கிற மாதிரி அதை பார்த்தா எப்படி இருக்கும்? That is the case. That is considered as a reflection. இதுல there is no change. Theta I is equal to theta r. Okay, இப்போ x பாத்தீங்கன்னா x தான் உங்களுக்கு தெரியும், y பாத்தீங்கன்னா மிரர்ல y தான் உங்களுக்கு தெரியும். So there is no change. It is considered as a reflection. Try to understand what is reflection. Okay, so theta I is equal to theta r. Okay, so it is considered as a reflected mirror மாதிரி imagine பண்ணிக்கங்க. Okay, yes. So any doubt in this? Next. So this is the principle. The reflection principle is applied to the fiber optic cables. Okay. So the first one, LED or laser, that is your light source. The transmitter. What is the next part we are using in the block diagram? Light source. So light source is nothing but LED or laser. Okay. So the light from LED or laser, it is passed through your core. It is on the core next cladding. Okay. So core we are passing that one. So it automatically strikes and reflected. Okay, எப்படி மிரர்ல உங்க இமேஜ் பட்டு ரிஃப்ளெக்ட் ஆகுதோ, the same way the light from LED or laser is strike that one in the core and reflected automatically. So please be remember, when the light is reflected, there is no change in speed or there is no change in angle. Theta I is equal to theta r. Okay, so இது வந்து next levelல என்ன இருக்கு? cladding குள்ள போக முடியாது. So that is what is the reason? That is the reason for total internal reflection. I will show in video. You can able to understand what is total internal reflection. Why it is not able to enter into the cladding. That is for critical angle. Okay, please. So the next one is a refraction. Please go to the refraction. So core. The next one cladding. Okay. So what is the meaning for refraction means? Okay, the light entered from one medium into another medium. So in our diagram, the first medium 1 is air. The medium 2 is water. So when it enters from medium 1 into medium 2, there is no reflection. The refraction is happen. Here, what is the meaning for refraction means? The light, small bending, it changes its direction. Okay, that is for okay, the reflect refraction. The medium play enter agudhu. So enter agumbodhu automatically, the very important one is the speed of the light is changes. It may increase or it may decrease, depends upon the material of the medium. Okay, so please be remember, the speed of the light is changes. It depends upon the medium, material of the medium. Okay, so please see this one. So the light waves passes through the core. Core ku mele enna irukku? Cladding is there. So our condition is theta should be greater than theta c. So critical angle the incident should be greater. Then only it is the reflected if happen. So the light waves not enter into the cladding. Cladding a touch pannum, then reflect. Cladding a touch pannum, then reflect. So reflection only happen, not refraction is happen here. What is the reason? Theta is greater than theta angle. Okay. Yes. You see this one. So here the bending of the light, it passes from one medium into another medium. Okay. Here the light bending is happen. Also the speed of the light is changes. Okay. So this for example already we discussed the moonlight. Okay. So moonlight the surface is okay. Surface may be smooth surface or rough surface. We discuss whether it is a reflection or a refraction. We discuss. Okay. But it is the only reflection. Okay. Because the water is not moving. The smooth means we can able to view our image. இப்போ தண்ணியில நீங்க நின்று பார்க்கும்போது எப்படி இருக்கும்? நம்ம image நமக்கு தெரியும். But இது தண்ணி ஓடும்போது if the water is moving means there is a wave is there. So then the wave is not able to view. But so it is not considered as a refraction. It is considered as a reflection only. Okay. Yes. So this is the example for this one. Yes. The next one is the refractive index. So speed of light in the air into the speed of light in the medium. That is for n is equal to c by v. The important one, refractive index. Okay, n is equal to c by v. So speed of light but air light and divided by medium. It may be different types of medium we are using. That is for water or diamond or etc. Okay. So if air, what is the refractive index? 1.003. But when you are doing small problems, it is considered a 1 only. In case of water, 1.33. Diamond refractive index is 2.4. And for ice, 1.3. Okay, yes. So first we try to understand what is reflection and what is refraction. Please wait.
Cable is made up of thin strands of glass or plastic. These strands carry information between two places in the form of light. As you know, glass is a dense medium that refracts light, but light does not refract inside a fiber optic cable. Do you know why the incident ray does not refract here? Well, we can understand the reason for this once we understand the process of total internal reflection. A ray of light passing from a dense medium to a rare medium refracts and bends away from the normal. Here, the angle of refraction is greater than the angle of incidence. When the angle of refraction is equal to 90 degrees, we get a critical angle, denoted by C. In this case, the angle of incidence is equal to the critical angle. But when the angle of incidence becomes greater than the critical angle, then the refracted ray does not enter the rare medium. Rather, it is reflected in the same medium. This is what we call total internal reflection.
So this is the principle we followed in our fiber optics cable. Total internal reflection. Okay, Li should be greater than Lc. That is, the incident angle should be greater than the critical angle.
Going back to the example of the optical fiber, the light ray hits the inside surface of the wall of the optical fiber at an angle greater than the critical angle. Due to this, the light ray reflects within the same medium. Remember, there are two necessary conditions for total internal reflection to happen. 1. The ray of light must be traveling from a dense medium to a rare medium. 2. The angle of incidence must be greater than the critical angle. Many optical instruments use the principle.
The next one, refraction.
In the previous part of this lesson, we saw what refraction of light is. It's simply the bending of light when it travels from one medium to another. The question I left you with was, why does light change its direction after entering another medium at an angle? Let's discuss that in detail. The change in direction of light occurs because of the change in the speed of light in that medium. When light enters another medium, there is a change in its speed. The speed may either increase or decrease depending on the medium. Note that when we say that the speed will increase, it does not mean that the speed will be greater than this value, which is the speed of light in vacuum. When the light is entering into the glass at an angle, it travels at a lesser speed than in air, and when it goes from glass to air, its speed increases. So it's because of this change in speed that the direction of light changes. But what if the light is entering perpendicular to the surface of the glass? Will its speed change? Yes, its speed will change, however, it does not bend this time. Yes, the refracted ray propagates in the same direction as the incident ray. Talking about the case when light enters at an angle, there is one more observation that we can make. Observe this part of the refraction. Observe the incident and refracted rays. We notice that the refracted ray is more towards the normal than the incident ray. When the light rays enter the glass from air, it bends, and it bends towards the normal. And from this refraction, we can see that when the light ray again enters the air, it bends away from the normal. So we can say that when the light travels from an optically rarer medium to an optically denser medium, it bends towards the normal. And when the light travels from an optically denser medium to an optically rarer medium, it bends away from the normal. What do we mean by optically rarer and denser mediums, by the way? An optical medium is a medium through which light can propagate. Since both air and glass are transparent, light can pass through them. So, both of them are optical mediums. What about rarer and denser? If the refractive medium is optically rarer compared to the incident medium, then the speed of light in it will be greater. And when the refractive medium is optically denser compared to the incident medium, the speed of light in it will be lesser.
So here, your speed of light, it depends upon the medium. Okay? Yes. Refractive index of the medium. Yes.
Note that in both cases, we are comparing the speed of light with the speed of light in the incident medium. So what do we understand by this? How can we summarize it? When light is traveling from an optically rarer medium to an optically denser medium, its speed will decrease and it will bend towards the normal. Whereas when the light is traveling from an optically denser medium to an optically rarer medium, its speed will increase and it will bend away from the normal. Now that this is clear, I want you to understand another concept. Now, instead of a glass slab, we have water, and also suppose that the ray of light is incident in the same direction. We can see that this angle is the same in both the cases. So will the refracted ray in this case travel in this direction only? In other words, will the angle of refraction be the same in both cases? No, the angle of refraction will be different in this case. In fact, the angle of refraction here is greater than the previous one.
So here, try to understand. The first one, the air. The second one, medium, is the glass. The second example, the first one medium is the air. The second one is the water. So here, the angle of incidence is same. That is for I, or you can here also you can consider as I. But the angle of refraction is different because the first medium is glass, the second medium is the water.
So what can we infer? We can say that the refraction of a light ray depends on the material medium on which light is incident. Yes, light rays will be refracted by different amounts in different materials.
After discussion, we will come here. Then the next one is the Snell's law. Please go through the diagram. So in first one law, reflection. Reflection, the angle of incidence is equal to angle of reflection. Theta I is equal to theta R. In some textbook, they are using the word for theta 1 and theta 2, both are same. Theta 1 is equal to theta 2. Okay. The second case, refraction. So refraction. So refraction, the light enters from medium 1 to medium 2. Depends upon the medium, the speed of the light is changes. So in previous video, we watched that one. Okay. The third one is the Snell's law, the same one. Okay. So what is the condition mean? N1 is medium 1 and N2 is the medium 2. It may be different types of medium. Okay. So N1 sine theta 1 is equal to N2 sine theta 2. So this is the basic condition for your Snell's law. Okay. So this is a relation between the path taken by a ray light crossing boundary of surfaces or separation. So it may be a boundary or separation, any one. Okay. So N1 sine theta 1 is equal to N2 sine theta 2. Okay. It may be air, from air to water or diamond or glass, it may be. Okay. So the conditions for N1 by N2 is equal to sine phi 2 by sine phi 1. And already we know N is equal to C by V. Okay. The same one we have to apply. Okay. So please see the examples. In the first one, okay, medium 1 is common for all the examples, but the medium 2 is changes. First one water, the second one glass, the third one diamond. Okay. So the angle of incidence, that is for 45 degrees, is common for all the three examples. But what about your angle of reflection? It changes from medium to medium. Okay. So for water, the angle of refraction is 32. The angle of refraction for your glass in this example is 28 and diamond is 17 degrees. Okay. So depends upon the medium, the angle of refraction and the speed of the light also changes. The next one is the optical modes. Okay. So basically we are having two mode of operation. Please see the diagram, single mode and multi-mode. Say for easy understanding, the single mode means only a single ray, that is for single optical ray, single light ray is passes. Okay. In case of multi-mode means multiple light rays or passes. That is the case. So what is meant by single mode? Only single light ray is allowed to enter into the core or passes through the core. But in case of multi-mode, means okay, multiple rays are passed inside the core. Okay. Please go through. So generally we prefer multi-mode. Okay, this is the economic one. Okay, but very, very long distances. Apart from multi-core, we can go for the single core. Okay. So the example shows the multi-core one. Please see this one. The due to total internal reflections, the light rays are not enter into the cladding. Okay, it reflected one by one and passes automatically. So here multiple rays are passing. So multi-mode example. Okay. Please go through what is single mode. Okay. So it is for only one path. So single mode fiber or best. Okay. So normally, but for economic purpose, we go for the multi-core. Okay. The next one is the mode. Okay. So mode analysis, single mode and multi-mode. Then we enter into the mode one. So before that, we see the Snell's law simple video. Please wait. it is a normal, some textbook, or it is considered as a perpendicular one. Both are same. Okay. Yes. So the medium 1 is the air, and the medium 2 N1, the medium 2 N2 is nothing but water. So your light is passed from medium 1 to medium 2, and what happens?
Fiber optic cable is widely used in wind farms to transmit information using light. It is a highly effective way for communication to occur between and within wind turbines. In general, the system consists of a transmitter to produce and encode the light signals, optical fiber to conduct the light signals, and an optical receiver at the destination to decode the light pulses and return.
So this is your input is electrical pulses. Again, it is converted into the optical signal. Okay, here consider as a light source. Okay, here photo detector is there. So optical signals are transmitted. In receiver end, again photo detector is there. So it converts your optical signal into light signal, electrical signals. Okay, output is the electrical signal.
Them to digital form. The electrical signals can be either digital or analog. Analog signals also require use of a pulse code modulator to convert them to digital form. The transmitter is composed of an interface circuit, source drive circuit, and the optical source. The interface circuit processes the electrical signal, making it compatible with the source drive circuit. In turn, the source drive circuit varies the current to modulate the optical signal. Finally, the optical source changes the electrical energy into light. The pulses of light are sent through the transparent core of the cable. The receiver consists of a photodetector, an amplifier, and a signal restorer. The photodetector transforms light pulses into electrical signals. It is light sensitive and must be capable of detecting even weak light pulses.
So here try to understand the receiver part only. So here the amplifier circuits and what are the amplifiers and signal restorer circuit is not necessary for us. Okay, so up to our syllabus, we have to understand the optical fiber communication principles. Okay, so these are the substitutes, these are the explanations, but you should know what are the things available in the receiver.
The amplifier increases the signals received from the photodetector. This is the primary source of electrical noise in the receiver, and the sensitivity of the receiver is dependent on minimizing this noise. Lastly, the signal restorer converts the amplified electrical signal into a form that is suitable for the interfacing circuitry. Quality transmitters and receivers work together to ensure less signal degradation across the network. However, long-distance fiber strands differ depending on the design of the core in relationship to the surrounding cladding. Depending on the type of light source used, the light waves propagating through the core may follow a variety of paths. A mode describes the path of a light wave as it travels through the core. The mode, or path, is determined by the angle of the light wave entering the strand and the refractive index of the cladding. If the angle of the entering light wave is too sharp, the wave will not propagate through the cable. There are single and multi-mode fiber optic strands. Both single mode and multi-mode.
So basically follow two mode of operation, single mode and multi-mode. Already we discussed single modes only single rays are passed. In multi-modes in multiple lights. So these are multiple light rays are passed. Okay.
Fibers are typically 125 microns in outside diameter, but the core is significantly smaller in a single mode fiber. Single mode fibers are approximately 5 to 10 microns in diameter. A single mode fiber strand is so minute that it allows a focused laser light entering the core to stay at an angle of 0 degrees without any loss into the cladding. Therefore, the bandwidth is almost infinite. It is commonly used to send data over great distances and at high speed.
So normally we prefer for long distances, especially for great distances. Okay, so for single strand only use பண்றோம். So losses are very much less. Normally fiber optic cables losses are reduced. Okay, theoretically we are telling zero loss, but there may be small losses is there. But especially for single core, we have considered as zero loss is there, because we are using only for single strand wire. Only one light ray is passed without 0-degree angle. Okay.
Multimode fiber has a larger core diameter of 50 to 100 microns. The most commonly used sizes are 50 or 62.5 microns in diameter. Multimode fiber can use either laser or LED light sources. The larger numerical aperture allows light waves to enter the core at a variety of angles. If the light wave enters the core at an angle close to 0 degrees, it is referred to as having a lower order mode. As the entering light wave deviates from 0 degrees, the order of the mode increases. The higher the order of the mode, the more the light wave will strike the cladding as it moves down the core. Consequently, a higher order mode takes longer to reach its destination. This timing difference between higher and lower modes creates modal dispersion and degrades system performance.
So try to understand this concept. Okay, light rays are forced through the core. What is this black? What is the second layer? Cladding. Okay, so due to total internal reflection principle, that is, for theta I should be greater than theta C. Okay, should be greater than your critical angle. So it is not enter into the cladding. Cladding தாண்டி போக முடியாது. So it automatically reflected. Okay, the light rays are reflected within this core.
As a result, multimode fiber strands are mostly used for data transmission.
So any doubt in this mode of operation? Next we enter into the mode analysis. Please see the diagram. The principle of total internal reflection. So already we know the basic construction. So the first inner side is your core, the outer part is cladding, the third one is your buffer, and the fourth one is your jacket. Okay, so medium 1 N1 and medium 2 is N2. So simple, similar to your refractive index. Okay, so we have to consider for the two conditions, N1 and N2. That is for, please see this one, this is for single mode and this is for your multi-mode. So your single mode fibers are capable for carrying only one signal of a specific wavelength. In case of your multi-mode means program, okay, that is for propagation along the fiber in zigzag fashion with total internal reflection principle. Okay, so here your kind of gliding is considered as your boundary. So the boundary is only the pohadu. Okay, so within this boundary it reflected. Okay, so condition 1 and condition 2, it is necessary for the mode analysis of optical fiber propagation. So what is the condition 1 means? If the refractive index of glass fiber is N1 and the refractive index of the cladding is N2. Already we know what is the refractive index. Okay, so N1 and N2 means N1 should be greater than N2. Already we discussed one more condition, that is for theta I should be greater than theta C. That is condition number 2. So condition number 1, N1 should be greater than N2. What is N1? Refractive index of the glass fiber, that is for core. The second one, refractive index of the cladding is N2. So N1 should be greater than N2. Refractive index of core should be greater than refractive index of the cladding. The second condition is the angle of incidence. Okay, then critical angle. You video okay, so theta I should be greater than theta C. That is the condition. So diagram point. Okay, we could apply the basic Pythagoras theorem. So this is N1 and N2. Okay, it's phi 1 or phi I. For each of phi 1 we are using. Okay, then the critical angle. This is for the square root of N1 minus N2 square. Okay. So consider our Snell's law, N1 51 equal to N1 52. So N1 50 is equal to N1 51, sorry, sin 51. Okay, what is 51 is nothing but, diagram பாருங்க, 51 is nothing but 90 minus 5c. Okay, so what is this one? 51 is nothing but, so this is one. Okay, so 90 degree minus 5c, we can write this one. So what is sin 51 is nothing but sin 90 minus 5c. So sin 90 minus theta is nothing but cos theta. Sin of 90 minus theta, cos theta. So cos 5c, we go to that one. So substitute that equation. அப்ப n0 sin 50. Okay, again replace பண்ணிருக்கேன். n0 sin 50 அப்படியே இருக்கட்டும். n1, if apart from sin 51 what we have to write? Here we have to write this cos 5c. இப்ப இது just replacement, n0 கீழே கொண்டு வந்துருங்க. So sin 50 is nothing but n1 by n0 and cos 5c. Up to this, any doubt you are having? So okay, as per Snell's law, the equation 1 is right. Now equation 1 போடாம மறந்துட்டு, please try to understand. Okay, so n0 sin 50 is equal to n1 sin 51. As per this diagram, what is 50 is nothing but 90 minus 5c. That's a substitute for me. Okay, but 51 to the substitute this one. Okay, then we are getting sin 90 minus theta cos theta. So substitute in this equation, rearrange this equation. I hope you have to understand up to this. Next, cos 5c. So as per your Pythagoras theorem, whatever your cos critical angle 5c is nothing but is, so square root of n1 squared minus n2 squared and divided by n1. This update to substitute this equation. Okay, the sin 50 okay, substitute the second in this equation. So n1 by n0 update இருக்கட்டும். Cos 5c substitute this cos 5c here. So n1 by n0 and square root of this one, continue. Okay, so sin 50, the previous equation, rewrite here the same one. Okay, so what is sin 50 is nothing but n1 and n1 cancel. So we are getting this one, square root of n1 squared minus n2 squared divided by n0. So what is 50 is nothing but this one. So it is considered as the accepting angle. What is 50 is nothing but a accepting angle, and your 50 max defines the maximum angle in which the light ray may incident on fiber to propagate down the fiber. Okay, so the two important one, accepting cone and accepting angle சொல்லுவாங்க. The first one is the accepting angle. Here this 50 is considered as the accepting angle. Only the simple derivation only. First Snell's law எழுதுறீங்க, then with the help of this diagram apply Pythagoras theorem, just to substitute your sin theta, then sin theta with the Snell's law equation apply பண்றீங்க, just rearrange பண்ணா we are getting the 50 value. Okay, yes. So it is considered as your angle of acceptance. Any doubt in this? Yes. The next one, acceptance cone. Please see the diagram. Diagram 1 for instance. So this is for your 50 max. Already also accepting angle. This is your core and this is your optical cable. And the next one is the cladding. Okay, buffer etc. is there. Okay, if consider rotating your cable. Okay, so light rays நீங்க pass பண்றீங்க within inside the core. இப்போ rotate பண்றதை imagine பண்ணி பாருங்க. That is for rotating the accepting angle. இப்போ உங்க 50 max நீங்க rotate பண்ணும்போது எப்படி இருக்கும்? Automatically it is acting as a cone shape. Light rays எப்படி வருதுன்னு பாருங்க. Second diagram பாருங்க. So if you rotate your core means it is acting as outputல வரும்போது the light rays வரும்போது it is shaped the cone shape நமக்கு we are getting. It is considered as your acceptance cone. Okay, so this pattern is considered as a acceptance cone of the fiber input. So the cone of acceptance is the angle within which the light is accepted into the core and is able to travel along the fiber. Okay, எதுக்காக acceptance cone அப்படின்னா input வந்து எந்த angle ல இருந்து நம்மால கொடுக்க முடியும், what is the minimum angle, what is the maximum angle, we have to discuss. Because the single mode அப்படின்னா no problem because input angle is 0. But in case of multi-core, okay, multi-mode of operation போகும்போது multiple rays are entered. அப்ப நீங்க rotate பண்ணீங்கன்னா the cone shapeல வரும். That is the maximum one. So all the multi-rays, இப்போ 5 rays அப்படின்னாலும் அந்த 5 light signals will be within this cone. அந்த cone shape குள்ள இருந்தா மட்டும்தான் it is able to reflect inside the core. Okay, அந்த cone shape விட்டு வெளியில போனா we are not able to reflect inside the core. That is the meaning for your acceptance cone. Okay, so previously we discussed acceptance angle. This is for your acceptance code. Okay. Please try to understand the case. Numerical aperture. Generally, it is considered as a NA. The formula is square root of N1 squared minus N2 squared. What is N1? We discussed in the previous one. It is for refractive index of the medium 1. And N2, refractive index of the medium 2. Okay. That is for in a medium 1 abina core. Medium 2 is nothing but cladding. In your fiber optic cable, medium 1 is nothing but inside is core. Okay. And the glass fiber wire. Medium 2 is nothing but cladding. Second part is the cladding 1. Okay. Yes. So what is the purpose of your NA means? Okay. So what is the maximum capability of light gathering? Okay. So with the help of this NA, so your numerical aperture, it gives the value. That is for square root of N1 squared minus N2 squared. What is the maximum capability of light gathering of your wire? Okay. Of your fiber optic cables, we can able to calculate. Okay. That is the case for your numerical aperture. Okay. The acceptance angle also determines how much the light is able to enter the fiber. So there is a relation between the numerical aperture and cone of acceptance. Okay. Yes. So first one, cone of acceptance, then accepting angle, then numerical aperture. Okay. I hope you may understand. Before entering into the waveguide, we see simple video. So why we go for fiber optics compared to your copper? Please wait.
Are faster than copper wire?
Please wait. So now we will see the video, why we go from copper wire to optical fiber. So what happens in the fiber optic cable? Okay.
Have you ever wondered why fiber optic cables are faster than copper wire? The answer, as it turns out, is pretty interesting. Copper wire has been used for electrical wiring since the very invention of the electromagnet and telegraph hundreds of years ago. When the telephone was invented in the late 1800s, copper wire became the go-to material for long-distance telecommunications. Copper would prove to be an invaluable material for many decades to come, until the invention of fiber optics in the 1950s. While it would take several more decades for fiber optic to be used widely for telecommunications, it would eventually supersede copper cables for many uses. But why? Fiber optic cables use pulses of light generated by an LED to transmit data along strands of glass or special plastics. Copper, on the other hand, relies on the transmission of electrical currents along its length to perform the same function. Data is transmitted on copper cables as electrical pulses. A detector receives and decodes the signal. However, the longer the signal travels, the more it deteriorates. This is a phenomenon referred to as signal attenuation. With fiber optic cables, the transmitter converts electronic information into pulses of light. The pulses are given in a binary system, with one pulse equating to a 1 and no pulse equating to a 0. When these light pulses reach the other end of the cable, an optical receiver converts the pulses or lack of pulses back into electronic information. So far, so good, although it might be important to understand what is meant by faster when comparing the two. When discussing the relative performance of either fiber optics or copper wire, the term faster is a little deceptive. Both fiber optic cables and copper wires transmit data at speeds slower than the speed of light in a vacuum, though some recent developments in fiber optics have managed to come closer to the speed of light. Yet either copper wire or fiber optic speeds could, in theory, transmit data around the Earth several times a second. For all intents and purposes, when comparing the speed of the two, what we are really talking about is something called throughput or capacity. These terms relate to the relative quantity of data transferred per unit of time. Fiber optic cables have, without a doubt, the higher throughput of the two, especially over long distances. A local area network using modern copper lines can usually handle around 3,000 telephone calls at any one time. Fiber optic cables, on the other hand, can usually handle more than 31,000 calls at a time. This difference in throughput of data is determined by the frequency range that either cable can manage. The higher the frequency range, the greater the bandwidth, and the more data that can be transmitted through the cable at any one time. This is the key difference between the two types of cable. Fiber optic cables have a significantly larger bandwidth capacity than their copper wire counterparts. For this reason, fiber optic cables can carry much higher frequency ranges than copper cables. Copper wire also has the problem of attenuation or signal loss at higher frequencies when compared to fiber optic cables. Fiber optic cables are also far less susceptible to noise and electromagnetic interference than copper wire, as the latter is made of metal. Another problem experienced by copper wire is that it can lose signal quality along its length. Over a distance of, say, 200 miles, fiber optic transmissions will show little or no loss of quality, while transmissions over copper wire will show significant degradation. So while copper wire is still used because it is cheaper than fiber optic cable and it is becoming faster, fiber optics still comes out on top for many uses.
So small overview about today's class. Okay. Now any doubt is in this class? So first the transmission system. So already saw in video. So video clearly they explain what is transmitter and what is receiver. So inside, so for transmitter side, we are having one light source is there, LED or laser. In receiver side, we are having one decoder. That is for photo detector. Okay. Yeah. So this is for the communication system. So why we go with higher bandwidth, low losses. So what is the main disadvantages means cost. Okay, so compare with your copper wire, optical fiber is the costly one. Okay. So these are the 4 parts for your cable. Try to understand. So here after the theory, they are using the word for core and cladding. So you have to understand what is core, what is cladding. The next one is your reflection. So basic law of optical reflection 1, then refraction, so what is the difference between reflection? The angle of incidence is equal to angle of reflection. Theta I is equal to theta R. But in refraction, the theta I is not equal to theta R. Okay, because it changes from medium 1 to medium 2. Okay. The next one is this Snell's law. So refractive index, try to understand. So N1 sin theta 1 is equal to N2 sin theta 2. N1 and N2 are medium 1 and medium 2. So this for the 3 different examples. Even though the angle of incidence is 45 degrees, the angle of refraction is changes because the medium is different, water, glass, or diamond. So optical mode, two modes, single mode and multi-mode. You know what is single mode and multi-mode. Okay. Normally we prefer multi-mode, but very, very long distances, we go for the single mode. So this is for the mode analysis. So mode analysis, we are having two conditions. Condition number one is N1 greater than N2. N1 is nothing but angle of, so that is for refractive index for the medium one. In a medium is nothing but your core. And N2 is nothing but, that is for your refractive index of the cladding. Okay. The second condition, theta I should be greater than theta C. Okay. So we apply simple equation. We are getting accepting angle, then accepting cone. The next one, numerical aperture, theta A. So what is the purpose of NA is nothing but, okay, what is the capability of the light gathering of the fiber optic cable? We have to calculate. Okay. Yes. Thank you. In next class, we continue the waveguides and these basic principles. Okay. Yes. Thank you. Can I any doubt in this one? Okay. Thank you. Thank you all.